Developing an electrical maintenance program involves several key elements. Firstly, regular inspections and testing are crucial. This includes visual inspections for loose connections, damage, or overheating. Supplement visual inspections with electrical testing such as insulation resistance testing and ground fault testing. Secondly, establish a maintenance schedule. This involves scheduling routine maintenance tasks such as cleaning and tightening connections. You should also schedule periodic overhauls, which may include transformer oil analysis. Thirdly, prepare emergency procedures. Create a response plan for power outages, fires, and other emergencies. Keep contact information for responsible personnel readily available. Fourthly, maintain thorough documentation and record keeping. This involves keeping maintenance logs, inspection reports, and test results. Fifthly, provide adequate training. Ensure personnel responsible for maintenance and emergency response are properly trained. Sixthly, implement preventive measures. These measures include surge protection, uninterruptible power supplies also known as UPS, and power factor correction. Seventhly, foster collaboration with the IT team. Coordinate with the IT team to minimize downtime during maintenance activities. Eighthly, prioritize safety considerations. Enforce lockout or tagout procedures and conduct an arc flash hazard analysis. Ninthly, manage the budget and resources. Allocate funds for maintenance activities and determine staffing and equipment requirements. To further enhance your understanding, consider these additional points. Review existing electrical drawings and documentation. Conduct a thorough assessment of the equipment, environment, and potential risks. Establish clear roles and responsibilities for maintenance personnel. Use a computerized maintenance management system, also known as CMMS, or a spreadsheet to track inspections, maintenance tasks, and documentation. Stay informed about industry best practices and emerging technologies. To help guide you, several resources are available. Consult NFPA 70, which is the National Electrical Code, also known as NEC. Refer to IEE 1584, which is a guide for performing arc flash hazard calculations. Investigate ETIM International, which is an electrical equipment identifier system. Explore the Electrical Maintenance Technology website. Consider resources from the Institute of Electrical and Electronics Engineers, also known as IEE. Review materials from the National Fire Protection Association, also known as NFPA. Use standards from the American Society for Testing and Materials, also known as ASTM. The National Electrical Code, or NEC, provides comprehensive standards for electrical installations. It covers wiring methods, overcurrent protection, grounding, and equipment installation. Article 645 specifically addresses information technology equipment rooms. However, even if your environment is not strictly classified as an information technology equipment room under Article 645, many of the principles and practices outlined in the NEC still apply. Proper grounding is crucial for safety and equipment protection. Ensure that all equipment is properly grounded according to NEC Article 250. Regularly inspect grounding, conductors, and connections to verify their integrity. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. Ensure that overcurrent protection devices are properly sized and installed according to NEC Article 240. Regularly inspect overcurrent protection devices to verify their proper operation. Wiring methods refer to the types of conductors and raceways used in electrical installations. Select wiring methods that are appropriate for the environment and the type of equipment being served. Follow the requirements of NEC Chapter 3 for wiring methods. Equipment installation refers to the proper installation of electrical equipment, such as panels, transformers, and generators. Ensure that equipment is installed according to the manufacturer's instructions and the requirements of NEC Article 110. Understanding the specific requirements outlined in these sections of the NEC can help you develop a maintenance program that aligns with industry standards and best practices. IEE 1584 provides guidance on performing arc flash hazard calculations. Arc flash is a dangerous electrical phenomenon that can occur when electrical equipment fails. Arc flash events can cause severe burns, injuries, and even death. IEEE 1584 provides methods for calculating the incident energy of an arc flash event. The incident energy is the amount of heat energy that a worker would be exposed to during an arc flash event. The incident energy is used to select appropriate personal protective equipment, also known as PPE, for workers who may be exposed to arc flash hazards. IEEE 1584 also provides guidance on reducing the risk of arc flash event. This includes implementing lockout or tagout procedures, using arc-resistant equipment, and increasing the distance between workers and energized equipment. Performing arc flash hazard calculations and implementing appropriate safety measures can help to protect workers from the dangers of arc flash. ETIM International provides a standardized system for classifying electrical equipment. The ETIM model classifies products based on their technical characteristics, such as their function, voltage, current, and dimensions. Using a standardized classification system can improve communication and collaboration between different stakeholders in the electrical industry. The Electrical Maintenance Technology website offers a wealth of information on electrical maintenance practices. The website includes articles, videos, and other resources on topics such as electrical safety, troubleshooting, and equipment maintenance. The website also offers online training courses on electrical maintenance topics. The Institute of Electrical and Electronics Engineers, or IEE, is a professional organization for electrical and electronics engineers. IEE publishes standards, journals, and conference proceedings on a wide range of electrical engineering topics. IEE also offers continuing education courses and certification programs for electrical engineers. The National Fire Protection Association, or NFPA, is a professional organization that develops and publishes codes and standards related to fire safety. NFPA publishes NFPA 70, the National Electrical Code, as well as other codes and standards related to electrical safety. NFPA also offers training courses and certification programs on fire safety topics. The American Society for Testing and Materials, or ASTM, is a professional organization that develops and publishes standards for materials, products, systems, and services. ASTM standards are used in a wide range of industries, including the electrical industry. ASTM standards cover topics such as electrical insulation, conductors, and equipment testing. Developing an electrical maintenance program is essential for ensuring the safety and reliability of electrical systems. By incorporating the elements outlined above and utilizing the resources available, you can create a program that meets the needs of your organization.